Okay, we're going to have a little look at regression. Watch this. All right, you're going to see this in a minute. Okay, what is regression? Okay, it's very simple. I've just changed my example, by the way. You should have hours revising and maths marks. At GCSE, you guys would have had a scatter graph. Here's the scatter graph of this. And you would have been asked to draw in a line of best fit, wouldn't you? There you go, bang. So at A-level, regression is about taking that one step further and finding the equation of the line of best fit. All right, what's the equation of that line? Now, in actual fact, we don't call it a line of best fit. We call it a regression line, and we call it the regression line of y on x. Okay, now you can see all this formula down the bottom, and I expect you're now panicking, aren't you? Oh, God, here we go again. Don't panic, don't panic, don't panic. Here he is. Right, the formula is here. There he is. Y equals, oh no, he always wants to move. Let's actually move him out of the way. Here's my formula. Y equals a plus bx. That is my formula for the regression line. It's all in your formula book. What's a? Here's a. This is a. A equals y bar minus bx bar. B, what's b? Here's b. B equals sxy over sxx. I can hear you going, yes, it's my little friend sxy, sxx. So here's sxx, that's the one down the bottom, and here's sxy. Dunno. So in actual fact, whoopee, there's one formula we can get rid of. So what I want you to do is, quite gorgeously in your book, can you scrub through the SYY formula? We don't need him, all right? And it's important that you recognise that he's not needed. Cross him out, all right, in your book. Okay, I've moved everything over. And in fact, I'm actually just going to get rid of him. All right, go away. Is he going away? Yeah, there he goes. Right, okay, so where do we begin? We're going to be beginning with this one. So we start with our B. Now, I've done the number crunching for all of this before. So actually I know from before, when I did correlation, because it's the same example, that SXY is 118 over 3. And I know that my SXX was 293 over 6. Now, of course, if I didn't have those, then I would have to use this formula and this formula in order to work it out, all right? So I'd need to kind of number crunch it. But I've got those already, so I'm just going to plug those in. Now, if I put those into my calculator tells me 0.80546075009, and I'm going to leave it as accurate as that. Okay, so we find B first. Now, once we've found B, then we can find our A. So here comes my A. And so A is found. Now, Y bar. Now, if you think about it, that is just the mean of Y. So Y bar is the sum of Y over N. Now, you're going to have to look back in your correlation table. But in my correlation, when I did correlation with this one, you can hopefully see that the sum of Y is 22, all right? Look back into your correlation pack. So Y bar is 22 over 6, so that's going in as 22 over 6, that's the mean of the Y's, minus B, which is this. Now, I personally am going to keep it in full accuracy to calculate it, all right? So that was my B in full accuracy, and it is timesing with the X bar. Now, X bar is, of course, the mean of the X's. So X bar will be the sum of X over N. And if you look again back in your tables, you should see that the sum of X is 619 over 6. So 619 over 6. Now, that all has to go very carefully in your calculator. My calculator gives me minus 79.43003413. Okay, so we've got our A, there's our A, and we've got our B, there's our B. And now we can pull out the final bit. So this is the equation of the regression line, and we just pop it all in. So Y equals A minus 79.43003413 plus B lots of X. I'm going to need a bit more space. Let me just move some of this up. Move up. Move up. Is he going to move up? No, he's not going to move up. So let's start writing him out again. So Y equals minus 79 0.43003 plus, what was my B? Here's my B, 0.8054607509x. And that is the equation of my line of best fit. Now, of course, that's crazy, isn't it? And it's probably neater to pop these to 3 sig figs. So minus 79.4 plus 0.8, 0.8, what's that rounding to 3 sig figs? 0.8, I've lost the plot now, 805x, all right? So that's it rounded to 3 sig figs. Okay, interpreting the A and the B is really important. If we have a little look at this, you can see that the line is in the form mx plus c, except they've obviously just written it round the other way. So in actual fact, the 0.805, which is the B, because the line is A plus BX, the B is 0.805. That looks to me a little bit like the gradient. And the A is like the C, isn't it? So the A is minus 79.4, which looks a little bit like where it cuts an y-axis. Okay, so let's see if we can plot this. Now, there's obviously a problem with my graph because can you see it starts, the hours spent revising start at 100, and actually in order for us to plot it, it should really start at 0. So I'm going to do a bit of a kind of fudge. I'm going to imagine that the axis has got a load of stuff on it here so that it actually comes to 0, okay? And my x-axis maths marks can be up here. What did they go up to? They went up to 8, didn't they? And then we'll go down. So my scatter crosses are actually right over in the right-hand side of the graph, and we could rub that bit there out, couldn't we? Okay, so there's my scatter graph. Right, let's see if we can plot a point. So the easiest thing to do to plot a point is to put in a value for x, say 108, and therefore y is minus 79.4 plus 0.805 times 108. If we do that on our calculator, my calculator is telling me 7.54. So I know roughly 7.54 is about here. Okay, so that's roughly where it is on my diagram. And then, of course, if we put in x is 0, we're going to get out y equals minus 79.4 plus 0.805 times 0, which gives us minus 79.4. Now, obviously, 79.4 if my line of best fit is roughly about there. So 70, it's not really properly to scale, is it? But minus 79.4 could be there. So that's my line of best fit. Now, the second thing that's really important is they're going to ask you to interpret the line. So I'm just going to move him up a little bit. That's what he looks like there. And they're going to ask us to interpret the A and interpret the B. Now, the A is here, isn't it? It's the minus 79.4. That's the A part there. So it's this bit here. Now, what we don't say is it cuts the y-axis at minus 79.4. We have to put it into some context. So what we write to interpret the A, let's write this in down here, is when. Now, what is it that we're looking at? It's hours spent revising, isn't it? When the hours spent revising is 0, the maths mark is minus 79.4. So you're putting it into context and you're saying when x is 0, y is minus 79.4, but you must write it. So when the hours spent revising is 0, the maths mark is minus 79.4. I know that's a bit strange. Okay, interpret B. Now, what was the B? This was the B here. So we've already said that the B is the same as M in the line y equals mx plus c. So the B is actually the gradient. Now you can't just say it's the gradient. What you have to say is this. For every extra 1 I go across, so for every extra 1 hour, for every extra 1 hour spent revising, the maths mark, I was about to say English then, the maths mark goes up by 0.805. All right. So that here is 0.805 up. Okay. You're basically saying for every one I go across, how many up do I go? Okay, here's another really classic question on the exam papers. Use your line to estimate the maths mark if you revise for 101 hours. Okay, so all we're going to do is we're just going to feed 101 into there, and it's like seeing what this value is here on the graph. Okay, so y equals minus 79.4 plus 0.805 times 101. Okay, now my calculator is giving that value as 1.905. About 2-ish, 1.905. Okay, so there's my answer. And then we think this is strange. We're doing it again with 110. So y equals minus 79.4 plus 0.805 times 110. And y is, I think I'm getting out 9.15. So if we'd extended our line, 8, I don't know, 110 could be somewhere like that, couldn't it? And we go up and then we go across. That's giving me 9.15. Now, that's weird. Why are they giving me 2? Are they giving marks away? Or what? No, they're trying to trip you up. Please be careful. Okay, it works like this. Why would they give me 2 the same? If you look back at your table, can you see that the lowest value in the table is 100 there? Okay, and the highest value in the table is 108 there. So your line of best fit actually only exists between 100, which is there, and 108, which is there. So this is the only section of the line of best fit that actually exists. The rest of it doesn't. And so what you need to say in answer to this question here is 110 is outside the range of the x's. Therefore, 9.15 is unreliable. And the posh word for that, which some of you might do if you're scientists, is you cannot use the line outside of these limits. So the posh way of saying it is, I can't extrapolate. Okay? Oh, they're not catching me out. Okay, here are your answers. Did you get that right? Y is 15.3 minus 1.7x. That's the equation of the line. All right, there's my line. And what else did we need to say? Okay, here they go. For every extra 1 hour revising, the English mark goes up by 1.7. If I revise for no hours, the English mark is 15.3. That's weird. Don't do that. That's not a good strategy. And the last bit, estimating the English mark if you revise for 6.5 hours, I got that as 4.25. And if you revise for 10 hours, it's minus 1.7. Can you see it's down there? Right down there at minus 1.7. But of course that's silly. We wouldn't just say it's silly because it's negative. Well, that is silly. We would say it's unreliable as 10 is outside the range of x, or if you want to be posh, you can't extrapolate. All right, get that right? Brilliant.